Hi, my name is Richard,
And I'm Paulo.
and we are Dormi, a home sleep test. So there are an estimated 4,700 sleep labs in the United States, and this makes up a market of $4.3 billion. Now these sleep labs use medical equipment to diagnose and monitor different sleep disorders as listed here. However, there's always the possibility that people are unfamiliar with the location of the sleep lab and feel that having a lot of electrodes in a foreign environment is really bad. So there exist home sleep tests. However, these only primarily target sleep apnea, and many other diseases are not targeted. These are made to be disposable units, so you send it out to the patient, and then after they're done, it's disposed of, yet they still range in cost from $250 to $500. These really only use pulse oximetry and nasal cannulae to measure airflow, and there's no real-time monitoring of data, so the physician has to wait for the patient to return with the data to move forward.
This is the Dormi Box. As you can see, it has a return address because the first difference between us and existing units is that we are reusable. Inside, we have three primary components. The first is a solid-state radar that also has cloud connectivity, so that any data collected by the system is uploaded to the cloud in real time and can be seen by the physician. To your right, you see the wireless pulse oximeter. Another goal of ours is that every item here does not need to be connected by wires, making sleep more comfortable and therefore giving more accurate results. We also have an airway mask because CO2 reading is a very important measure that's not connected by any other of these sensors. So together, these are able to send data, but for the purposes of the hackathon, we wanted to focus on the radar in particular because pulse oximetry and CO2 measuring have a long technical history, but this phased radar is a new technology that has many exciting medical opportunities that we wanted to prove it could explore. Fortunately, we had the opportunity to explore those during the hackathon because we were able to collect data sleeping here overnight. That data was collected by that wall-mounted unit there, which is our phased radar. You can see a plot out of that raw data at the top, and you can see it kind of falls into two distinct regions. The first of those is if you sleep facing the radar, because you have a greater chest motion toward it. And the second of those is if you sleep perpendicular to the radar. So if you sleep perpendicular, as you can see in the next row, there is a little bit of a smaller amplitude, but if you put that through a Fourier analysis, you can still see a strong band in the frequency domain, indicating that even if you get a weak signal, you can still strongly identify the breathing rate of the sleeping individual. Now, for deployment and our kind of market strategy. This is most useful for rural populations that are underserved by traditional brick and mortar sleep clinics. This should be distributed on a prescriptive basis by physician referral, and this is unique in that it's open for a physician to view data in real time. This would be an example of the physician GUI. Notice that we are able to allow the physician to contact the patient in case of an emergency because this data is real time and they can see if there's any issues. And even if we have a higher upfront cost because of the expense of the radar and other high-tech equipment we plan to use, it will be a lower long-term cost because both the pulse oximeter and the radar don't require very much maintenance and are reusable. So this can be sent back to the deployment center in the same package it was sent, and then refurbished and sent out again.
So most people sleep with blankets on. How does that affect your technology?
If you go back to that picture, you'll notice that he does sleep with a blanket on. It doesn't affect it, as long as your blanket doesn't have Mylar in it.
Right.
So again, is he wearing something that the radar detects, or it's just the body itself?
The radar detects body motion, so anything that oscillates in that space, the radar will detect. The radar is also penetrative, so theoretically we could do this behind a sheet of drywall, or this could be placed underneath the mattress. But for ease of installation, we would just want to put this on the wall using a mounting hook or something of that sort. The goal is for it to be as easy to install as possible, so you can install this with minimal remote assistance.
Can you envision the data from this device, from this home sleep test, will help inform a more conventional sleep test, which includes EEG and EMG, and you have all these other things that a sleep lab gathers. So how do the two integrate?
So we considered incorporating an EEG, which is really the one big thing that our current model, that our current package doesn't have. But we actually talked with multiple clinicians about this, and the EEG is a bit, the most major reason we dropped it is because it's difficult for a layperson to install. They have to put a bunch of electrodes in the correct location. Those wires have to really be physical wires. Unlike the other sensors, the data an EEG produces doesn't go well for wireless transmission. So it's much harder to set up than like a pulse oximeter would be, which can be done over BLE, over any other kind of wireless transmission.
What is your cost of goods sold? How much does it cost you to make these?
We have been doing a bit of back of envelope calculations as to what this would cost. One big thing is the most expensive component by far is that phased radar. That is $160. We could get the price down if we, instead of buying it from a third party, manufactured it ourselves. Thank you.